Network is just disturbing these days. Okay, network is seriously disturbing these days. Let me see. I think the network, went down a bit a moment ago. Let me check and see what is happening before I kick off the class fully. Let's see. I would always be checking. Are you following right? To be sure that your friends are still on. Okay, so we are going to move on straight to talk about power law of indices. What does the law state? I'm going to take it grammatically, and then we'll look at the mathematical expression for this law. Okay? The network. So we're going to make sure that we are patient enough in this class. Okay? As often as I can, I will go check the network situation. It's just hanging and hanging and hanging. Let me see. It's just hanging and hanging and hanging. Let me boost the network and see what happens. So, power law of indices. It states that if a base is raised to 2 or more powers, if a base is raised to 2 or more powers, simply multiply the powers. You are to maintain the base. You would maintain the base, carry the base along like that. Then the powers of the base, multiply them. That is what power law of indices is all about. I've stated it grammatically. If a base is raised to 2 or more powers, maintain the base like that and do what to the powers I said. Multiply the powers. So mathematically, that law can be expressed as this, assuming that I have x to the power of a, and then I multiply this to another power, rather. I have another power to read b. This could continue. There could be more powers there. Because, of course, one can give you, okay, x to the power of a, to the power of b, to the power of c, to the power of d, The law simply said you should maintain the base the way it is and do what to the powers? Multiply the powers. So if you have more powers, you will continue in that way. That is what power law of indices tells us. How well do you understand this law? Don't play with this class. There is a reason I decided to pick this particular law out of the 5 major laws of indices to talk about it in this live class. Okay? You're welcome to the class. Kabir, hello. You're welcome. You're welcome. You're welcome. And to the rest of you friends who joined, it's your girl, Peyton. You're welcome to the class. Okay. Ragav, teach integration. Don't worry. Always stay connected to our class, okay? When it is time for integration, you're going to learn it. However, on this channel, you have wonderful live classes, pre-recorded videos on integration. Make use of them. Pending any time, I might just teach any little thing on integration, okay? Please let us move on. This is all about power law of indices. The application is not the most important thing. The application is the most important thing. One of the application of power when dealing with power law is the fact that power is distributive. Power is what I said, distributive. I refer to it as the distributive nature of power. Okay, now having said this, let me try to show you what I mean. Please, before I move on, look at this term. If you write your x, it's going to be a times b times c times d. Now, sometimes when I see some of these Olympiad maths, I'll just laugh and other things. And I look at it, I said, just imagine the way they play with people, in terms of the knowledge of power law of indices. Okay? Yeah. Most of all these Olympiad maths, they use much of this knowledge. Okay, so this is power law of indices. What are certain things you should know about power in indices? What should you know about power in indices? One thing I want you to know here is that under indices, when you're talking about power, power is distributive over multiplication and division. Power is what I said, distributive over multiplication and division. So as a scholar, as a student, when you are dealing with indices, you come to power law of indices. Don't just learn that power law that, okay, if you have a base and it has two or more powers, simply multiply the powers. Yes, we know, we understand that. That if I have a base, like in this case, e.g., if I have, let's say, 2 to the power of 2 to the power of 3. This is going to give us 2 to the power of 2 times 3. And of course, we are going to have 2 to the power of 6. And 2 to the power of 6 should give us 64, right? Yeah. So this is 64. 2 to the power of 2 brackets 3. Yes, we understand this. But is this where the idea of the laws of the power law of indices, is this where it ends? What more should you know about power law of indices? So one of it I said is the distributive nature of power when you are dealing with indices. It's something that a student should know very well, because there is one other area that some students misuse this distributive law. Wait a minute, but come with me, let me show you this. Like I said, note distributive law or nature, distributive nature of power. Of what? Power. Power of a term. Okay, simply distributive nature of power. Now I said that power distributes over multiplication and division. So you want to take note of that. Power distributes over multiplication and division. Multiplication and division. As a scholar, you want to have this in mind. Multiplication and division. So what does that mean? If I give you x times y, let us say x raised to any power times y raised to any power, and then I raise this to power c. You see this power outside, it will distribute. This point means multiplication place. This point represents multiplication. This power outside will distribute to the x and to the y. A scholar is expected to know this very well. And in mathematics, are you following, right? This concept is very useful. In several aspects of even these indices, and you go further, you meet this idea, you meet this concept. Is it in physics? Come to the study of field. For example, you talk about magnetic field, electric field, you meet this concept. I'm going to give you a quick example. Look at this law. Either Coulomb's law of electricity in physics under electric field, or Newton's law of universal gravitation. Newton's law of universal gravitation. That denominator that usually carry r square of the distance. Imagine that I tell you that the distance between, let's say, two masses or two charges is 5 times 10 to the power of 2. 5 times 10 to the power of, okay, let me make it to the power of minus 5. 5 times 10 to the power of minus 5. That is the distance between two masses or between two charges. If you are substituting into that formula, that Coulomb's law or that Newton's law of universal gravitation, that denominator, this is the law I'm talking about, F. Okay, let me just talk about the Newton's law of universal gravitation, G m1 m2 divided by r squared. If the distance between these two masses is 5 times 10 to the power of minus 5, say in meter, for example. If you are substituting here for this distance r, since this r is carrying square, you have to put all this in bracket and do what? Square. This is very good. Now, for you to simplify this, you must remember the distributive nature of power. You must remember the distributive nature of what? Power. Otherwise, you will have problems solving it. Are you following right? Part-2, same as electrostatic force. That's good. You are correct about that. For electrostatic force, this will be equal to K, Q1, Q2 all over R squared. So, but why did I give you this example? I gave you this example to tell you the importance of what we are trying to do here. So in this case, this will be equal to, I'm giving you e.g. here, example. This will be equal to x to the power of a times c. This power c will distribute to this x to the power of a and y to the power of b. Since there is, in fact, let me write multiplication here. Since there is multiplication between them, this power will affect each of them. So we're going to have times y to the power of b times c. So you take note of this. Like if you come to this term now, this 2 will affect this 5. So you get 5 squared. And this 2 will affect this 10 raised to power minus 5. But because this 10 has its own power, you will now go back to use the main power law. What power law states, you now apply it here. Because in this case, why this 5 will be squared? Because this 5 here is raised to power 1. It's going to be 5 raised to power 1 raised to power 2. So 1 times 2 will give you 5 raised to power 2, which is 5 squared. You get 25 there. If you come here, 10 raised to power minus 5 will be raised to power 2. Because this power is distributed to this 5 and 10 because of this multiplication. If you have 10 raised to power minus 5 and then raised to power 2, minus 5 will now multiply 2 to give you 10 to the power of minus 10. So that this whole term is 25 times 10 to the power of minus 10. If you do not understand this idea of power law of indices, it will become very difficult to solve problems like this, assuming you are seated in exam hall. We are not done. Let's move on to the second important thing you should know about the distributive nature of power. Power is distributive. Power distributes over division also. Power distributes over division. A scholar is expected to know this. Okay, I think I even wrote it here. Power is distributive over multiplication and division. Sorry, I didn't take note of that. So no need of repeating for that of division. I'll just give you examples straight again. Another e.g. example. X to the power of a divided by y to the power of b. And then this whole term is raised to the power of c. Remember that the power can be a fraction. The power can be what? A fraction. This will now be equal to, because power distributes over multiplication and division, it distributes over division, this will become x to the power of a, you multiply it by this power c, all over y to the power of b. That power b, you multiply that power by what? C. So you distribute the power to the terms being divided, and then you apply the main power law. So GMAETS 41 is emphasizing it. See, it is possible that some of you, or most of you, have idea about this. But it's not just about having the idea, but here we are trying to re-emphasize, to talk about it again, and again, because of the importance of this distributive nature of power. You meet these things a lot when you talk about physics. And in fact, under indices and indicial equation, you make use of this knowledge a lot as well too. Now, why should a student be interested in this thing that I've written out? Why? Why should a student be interested in it? I'm going to now show you why. you should take what I am showing you here today very seriously. Just imagine, out of the whole laws of indices, I just picked the power law for us to talk about in this class. A danger area. A danger area. A gray area. Something that you don't want to do. Never try this, what I'm about to show you. Please. Take note of it, because I have met several students. I have seen several students, both people that I teach at secondary school level, right, at university level, who misinterpret or who think that this is possible under power law. I'm going to show you. I don't know if I can manage this part. Let me see if I can manage it. Let me see if I can manage so that I will not wipe this from the board. Please don't try this. Note, the following is not allowed. The following is not allowed, or possible, or not possible, or not possible. Okay? Because power distributes over multiplication and division. Then somebody will now come and tell you, okay, we can also do that for addition and subtraction. Please, no, no, no. Power does not distribute over addition and subtraction. Remember, I told you that anytime GMAETS 41 comes on live, going further, you know, for this 2025-2026 academic section to begin, to start this September, October, I'll be emphasizing seriously on key things that students want to take note of. I mean, if you are studying, if you are reading your books, you see there are areas, foundations, key points you don't play with. You want to again and again make sure you think about that thing, make sure you say it over and over again. Let that thing become part of you so that you will never forget it. It will help you a lot whenever you are moving further to other higher aspects. So look at this. Note, the following is not possible. And what is it? Power, let me make it as number 2. Now let this be number 1. Then number 2, power does not distribute. Power does not. Let me write this not in capital letter. I think the network is disturbing somehow. I don't know, just shaking. I guess so. Please be patient. Let me boost the network, right? What is happening? This thing is shaking here. It's shaking somehow. Let me boost the network. You might be logged out. Don't go away. Stay on. Once I upgrade the network, you'll be logged in immediately. Because this thing seems to be shaking somehow. I don't know why. Right? Let me check, please, the camera. Please permit me to boost. I don't know why this thing is shaking this way. I don't know. It's just blinking. I don't know why. I can't explain the reason, but I think I'll have to continue. Okay, I think I'll have to continue. At least the board is not blurred. The board is not blurred. Okay, the shaking is coming a bit. This is serious. All right, let's continue, please. The board is still clear, okay? The board is still clear. This person that posted this thing last, you're funny. I am going to impose 1,000 tariff on you. Okay, no problem. Account, hello teacher. Hello, you're welcome, account. I hope you're doing fine. Intense 2.0, where are you from? I am from Nigeria. So this class is streaming live from Nigeria. Is that okay? Oka in Anambra State specifically. Let's move on, please. I was going to say that power does not distribute. So I want to write that not very big. Power does not distribute over addition and subtraction. Over addition and subtraction. Power does not distribute over addition and subtraction. Take note. So here we learned that power distributes over multiplication. It distributes over division. But what of distributing over addition and subtraction? It does not work that way. E.g., you cannot do this in maths. You can't. You can't do this. It's not correct. Imagine that I give you x to the power of a plus y to the power of b. And then you have power c. Take note that this a and b, they are numbers, okay, likely numbers, and they can be 1. If a is 1, this will simply be x raised to power 1, which is x. If b is 1, this will be y raised to power 1, which is simply y. So that you'll be having x plus y in bracket raised to power c. You can't do this. This is not equal to c. Not equal to. It is not the same as x to the power of a times c plus y to the power of b times c. You cannot do this. Okay, let me put it here. This is not equal to x to the power of a times b. Is it times b or times c? Times c plus y to the power of b times c. This is not equal to this. You can't do it. This thing is wrong. It's wrong. So let me write it. Wrong. Wrong. If you ever do this thing, it is wrong. Okay? So if I give you something like, let me assume that I give you something like, let's say 2, okay, plus x raised to power 3. You cannot, take note, you cannot do this. This is not, you cannot do this. Say equal to 2 raised to power 3 plus x raised to power 3. If you ever try this, this is very wrong. I will fail you. This is wrong. 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 You can't distribute. Power cannot distribute over addition and subtraction. It can't. So take note of that. Let me wipe it off because that is wrong. That is wrong. Again, if it were to be subtraction, suppose that was subtraction, power can't be distributed over those terms in subtraction. You can't do it. So look at the other one. Another thing you want to take note of, e.g., if this were to be x to the power of a minus y to the power of b raised to power c, it is not equal to, it's not the same as x to the power of a times c minus y to the power of b times c. This is wrong. If you do it, it is wrong for addition and subtraction. If you do it, it is wrong. That is why if somebody gives you this, look at, if I give you something like square root of 4 minus x, square root of 4 minus x, you can't do this. If you say that, if you write equal to square root of 4 minus square root of x, you are very wrong. Wrong. Let me write it big. Wrong. Wrong. You can't do this. You know, most times if a student sees, because 4 is a perfect square, oh, square root of 4, you go and split square root to this 4, then minus square root of x, so that you say square root of 4 is 2. you do that, you are wrong in this case. Why? Because of this minus. You're going to find out under fractional index law, that square root means raised to power half. Like this square root now, this square root is the same as raised to power half. So 4 minus x, everything in bracket, raised to power half. That is the meaning of square root of 4 minus x. That is the meaning. Look at it. So you splitting the square root over this 4 and x is very wrong, because power cannot distribute over subtraction. Power cannot. So you cannot break this thing down to half square root of 4. If you try it, your teacher, your examiner will fail you. We are moving on. Your comments here are so funny, so I don't want to read them out. So please, dear friends, take note of these principles under power law. You don't play with them. You don't. You want to remember that you can distribute power over multiplication and division terms. You can do that. You want to remember you cannot distribute power over addition and subtraction. You can't do that. You can't do that. Now, based on what I explained here, see this term, this point about multiplication, power distributing over multiplication, and power distributing over division. Because of this distributive nature of power, it can allow you to do a form of factorization sometimes. It can allow you to do a form of factorization sometimes when you are dealing with an indicial problem. You are dealing with a problem relating to indices. Because of this distributive nature of power over multiplication and division, it can allow you to do what I'm about to show you next. So I will wipe this part of the board. Right? Please, once you join the class, hit the like button. Okay? Hit the like button. Ara, what class do you teach? Well, I teach all levels of learning. I teach all levels of learning, okay? This particular class you're seeing, this particular class is for those in grade 11, those in grade 10, grade 11, grade 12, and those in advanced level, 100 level specifically, or those who are into international foundation year. Okay, they are the ones that this class is meant for. This class is meant for these ones. I repeat again, grade 10. Here in Nigeria, we call it SS1. Grade 11, SS2 here in Nigeria. Grade 12, SS3. After which, they take their professional exam, WAEC, NECO, JAM, and whatever, GCE. They will take their GCE. And of course, those in advanced level, like I said, 100 level student, they also do this. So this class is meant for all these levels that I mentioned. Nice teaching, so thank you very much, Ara. I appreciate that. Thank you for joining us. Kai O, I'm jacking it. I don't know. I'm jacking it. All right. Okay. You're studying it. I hope so. That's good. Keep it up. So please, next class on calculus. All right. Well, we have a scheme that we follow. All right. We have a scheme. Become a member of GMAT 41. Send message to this contact, so you'll be added to our WhatsApp group, through which you can make certain requests. But please become a channel member on diamond level on this channel so you can get these benefits. Okay, in that case, you can make certain special requests, like you talk about calculus. Here we have treated calculus, wonderful video lessons on them, both pre-recorded and life classes. We've treated them. But now, assuming that you need this, fine. You make a special request. To do that, remember this is a full online school. GMAT 41 is a full online school. So you have to become a channel member. To become a channel member, join on the diamond level. Once you join, send a message to this contact. So you'll be added to our WhatsApp group for further follow-up. Okay, another thing you want to take note about power law of indices is point number 3. Point number 3. Due to the distributive nature of power over multiplication and division, it can allow you to factorize a common power. It can allow you to factorize a common power. I'm going to show you. Assuming I have x raised to the power of 4. Okay, let me use, a standard for it. X to the power of a times y to the power of a. Okay. Now, what happened here is simply x times y to the power of a. That was what gave us this. Because like I said, this power a will distribute over x and y because of this multiplication to be distributed to x and y. So that this will give us x to the power of a times y to the power of what? A. Now you notice that they have common powers. Therefore, if I have something like this, I can pull out the common power. So I will now have x times y to the power of a. Correct. The same thing with division. Let us say 3a and then 3b. Point 3a and point 3b. Applications of power law. Applications of power law of indices. What you should know about that law. I think that law has a lot of things, information to give to us. Now, if this were to be division, let's say x to the power of b all over y to the power of b, okay? Again, because they have the same power, since power distributes over division, you can still factorize that common power. This is the same as x divided by y all raised to power b, correct? Because in this form, that was how we distributed this b to x and y in order to get this term. So for that reason, you can still factorize out that common power. Love from India, Ara, thank you. Love from here too, all right? All right, dear friends, I think the things I want you to know about power laws of indices, I have established them. I'm going to look at the time and see if I can just show you few examples, nothing serious, okay? Because I just want to point out these things. Once you know these things, when questions are given to you on indices that involves power law, or when questions are given to you on any other subject or course that will involve indices process, because most times we meet something about power. If it requires power law and you encounter any one of these, you should be able to know what to do. Okay, so let me check how long we've spent, because this is supposed to be 1 hour class, not more than it. Okay, this we'll still have there about 15 minutes or so. Okay, so I think I want us to consider the following examples. Consider the following simple examples, okay? Simplify the following. Simplify the following. Simplify the following. This is question. Let's take this as question 1. Simplify the following. Imagine that I give you A, question A. Are you there? Good. Five to the power of minus 2 to the power of 4. 5 to the power of minus 2 to the power of 4. Then B, I give you this. Trying to crack my brain to come up with certain things I want you to take note of. Okay, so we have 4x, okay, 4x to the power, okay, let's say 4x squared to the power of half. 4x squared to the power of half. Let us use the knowledge of what we have explained so far to solve these problems. So these are just simple problems, like I said, okay? These are simple problems. Greetings from North Korea, Aniket Rai. You're welcome to join us. Greetings from here as well too. And I hope your friends are coping and doing well over there. Welcome to join GMAETS 41. Please, if you have not subscribed yet, quickly click on the subscription icon right away, okay? After you subscribe, turn on the notification bell and select all, so that anytime I come on live, you'll be notified, or if I upload any video content, you will be notified by YouTube. Meanwhile, I told you, friends, in our last class that from September 1, I'm going to tell you the days that I'll be having live class and the time. So let me use this opportunity and make it known to you, friends. Starting from today, 1st of September, GMAETS 41 will be coming on live every 8 p.m. on Monday, Wednesday, Friday. Once again, on Monday, 8 p.m. Nigerian time, 8 p.m. Nigerian time, West African time, right? I will come on live. 8 p.m. here in Nigeria is evening time, evening stroke night, okay? Yeah. That was about almost the same time I started this particular class, today being Monday, 1st of September. On Wednesday, 8 p.m. also, I'll be on live. We'll have like 1 hour class, okay? On Friday, the same thing. And courses we are going to be dealing with specifically in our live classes are physics courses, chemistry courses, maths courses. Is that okay? So make sure you stick around. Biology, I'll start releasing works on biology, but those are going to be on pre-recorded video lectures. Okay? Pre-recorded video lectures. So make sure you always stay tuned. I've told you the days I'll be coming on live. So if you have not subscribed, subscribe so that once I come on, you receive notification immediately from YouTube, you connect. Anytime you come to this class, there is something you must learn, and learn very well, that you would never have really imagined or thought about in that direction. That's a promise I'm giving to you. Now, this first part of the question, we're going to give you -8. Generally, examiners do not like leaving answers like this in negative index. In negative index form. This is negative power. Examiners don't like leaving their answers this way. That is why you should also know reciprocal law in indices, negative index law, which converts to reciprocal law. 5 raised to the power -8, according to negative index law, which you convert to reciprocal, it states that you should take reciprocal of the base. Reciprocal of any term is 1 over that term. Reciprocal of GMAETS 41 is 1 over GMAETS 41. Reciprocal of you, dear friends, is 1 over you, dear friends. So once I have negative power, I have to take the reciprocal, although this now depends on how the options are presented. Okay? But I know most generally as an educator, as a teacher, and of course, an examiner for about 14 years, all right? Most times we present this option in fraction form. So if it were to be theory, you don't leave it here, you don't. You have to convert it to 1 over the base 5, which is reciprocal of the base 5. Then the sign of the power will change. The sign of the power will change. From minus, it will change to plus. Remember that plus and minus, they go together. Minus changes to plus, plus changes to minus. On the GMAETS 41 basic class channel, that's our second channel dedicated to scholars in basic level of learning, basic 4 to basic 9. I've explained all these concepts of Plus and minus going together. Multiplication and division going together. That is why if plus crosses equality sign, it will change to minus. If minus crosses equality sign, it will change to plus. All right, we are moving on. We are moving on. If you must simplify this, of course, you know how to get it. 5 raised to the power 8 is 5 times 5 times 5 times 5 times 5 in 8 places. So you can work it out to get a single answer for it. 5 times 5, 25. Another 5 times 5, 25. You can work on 25 times 5. You get that one. Then multiply by the same result. Okay? If I work on 25 times 25, this is 5. And then this is going to be 125. Again, 125. So 5, 7, and 3, 1. So if you multiply 1375 by another 1375, the result you are going to get, the answer you will get from this multiplication, 1375 divided by 1375. The answer you will get from this product is equal to this denominator. Is equal to 5 raised to the power of 8. Okay, so let us take the second question. Let us take the second question. And I think I'm going to wipe this part. Let's take the second question. The B part of question number 1. The B part of question number 1. So in the B part of question number 1, we have 4x squared in brackets to the power of half. So how do we solve this? Now you apply the knowledge of the fact that power distributes over multiplication. Remember, this is 4 times squared x. 4 times squared x. That is the meaning of what you have here. So this 4 times squared x is raised to power half. So that power half will be distributed to 4 and squared x because these terms are being multiplied. So this is going to be equal to 4 raised to, you distribute this half to it, so 4 to the power of half times x squared to the power of half. That's what you're going to get. Now, 4 to the power of half is the same as square root of 4. Power half is square root. Power half is actually second root. Look at, there is invisible 2 here. Take note. If I have 4 raised to power half, according to fractional index law of indices, it states that if you have something like this, take the denominator root of the base. Take the denominator root of the base. Then raise everything to the power of the numerator. Which means that 4 raised to power half is the same as denominator root. Denominator here is 2. So it becomes second root of the base 4, all raised to power 1. And second root is simply the same as square root. Second root is simply the same as what? Square root. So this raised to power half, you're seeing here, 4 raised to power half is simply square root of 4. So please, if you had not known that raised to power half is square root of whatever that is carrying the half as power. If you never knew that, I have told you. So make sure you take it to heart. So square root of 4 is going to give you 2. But I don't want to solve it that way. I don't want to just go straight ahead as square root of 4 to get 2. This is meant to give us 2. I want us to do something else, at least to improve our knowledge. This 4 is the same as 2 raised to power 2. 4 here is the same as 2 raised to power 2. What I'm trying to do here is a case where you are not allowed to use calculator. So if 4 is the same as 2 to the power of 2, in place of this 4, I'll fix 2 to the power 2. This 4 is raised to power half. You can see it. Therefore, this 2 raised to power 2 will carry power half outside. So times x squared, then power half. Now remember that power distributes. Okay, is it power distributes now? Direct power law. If a base has 2 or more powers, if a base is raised to a power of 2 or more terms, Simply multiply out the power. So this is going to be 2 raised to the power 2 times half. 2 times half, this half we cancel, this 2 we cancel this 2. The same thing, this 2 we cancel this 2. It's the same as taking square root of a perfect square. So this simply becomes 2 times x. 2 times what? X. Therefore, we conclude 4x squared raised to power half is equal to 2x. That is very simple. That is very simple. Okay, that is very simple. Now, if I had given you this, what could you have done? Imagine I give you square roots. In fact, let me put it in question form. Question 2. Question 2. Question 2 is are you there? So I'm going to give you one funny thing. Okay, is 3 minus x raised to power 2 equal to 9 minus x squared. This is a question. This is a question. This is a question. Think is 3 minus x in bracket all square equal to 9 minus x squared? Answer. Answer. No. 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 3 minus x in bracket all square is not equal to 9 minus x squared. It's not equal to. What I did here to get 9 minus x squared was actually to distribute this square to 3 and x. 3 square, 9. And then x raised to power 2. This is wrong. Are you following, right? And that's what I've said. What is the reason? Power does not distribute over subtraction. This is because power does not distribute over addition and subtraction, over addition and subtraction. You cannot distribute power over this mathematical operation. So you see this, for you to solve it, 3 minus x all raised to power 2. For you to solve it, you can use binomial expansion. In fact, that's what we use, binomial expansion. Or you can decide to go this way. Let me show it here. 3 minus x all square is the same as 3 minus x in bracket times another 3 minus x times another 3 minus x. This is how you solve this. And if you expand this, you expand it, 3 times 3 will give you 9. 3 times minus x will give you minus 3x. Then minus x, I've used this 3 to multiply this bracket. 3 times 3, 9. 3 times x, minus 3x. Now use this minus x to multiply this bracket. Minus x times 3 will give you minus 3x again. And then minus x times minus x here will give you plus x squared. So if you simplify this, you will get 9 minus 3x minus 3x will give you minus 6x, then plus squared x. So this is the answer. This is the answer of 3 minus x in bracket all squared. Either using binomial expansion or using normal expansion process. This is normal expansion process. But in advanced maths, we deal with, the concept of binomial expansion, either in advanced maths for 100 level students or if you are studying further mathematics, okay, you meet it. So do you see that this is not equal to this? It's not. It's not. Rather, this is the correct answer. Well, I'm going to wipe this because this is not what I am teaching you. On our basic channel, I will teach those that will connect to that channel. I'll teach them expansion, how to do normal expansion, because that topic is actually basic maths. Okay, for those in basic level of learning. All right. We have done a lot of things, right? Okay, let's take our last question. 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 Question 3. Simplify. Simplify. Let us say, okay, 5 raised to the power 2 times, I'm going to say, okay, I'm trying to crack my brain to bring out something. This is not a class of coming to pick a kind of professional exam questions to solve. That's not the purpose of this class. But the purpose of this class is to give you the knowledge you need to be able to solve professional exam questions. So I'm trying to crack my brain, brainstorm and come up with what I want you to know. So I said this is times 3 to the power of 2. Okay? So just simplify this. How can someone solve this if need be? How can someone solve this? Or should I still make it a bit more complex? Perhaps I can leave it like this, just simplify this term. Or maybe let me fix it this way. Let me fix it this way. Simplify 5 raised to the power 2 times y raised to the power 2. Just as simple as that. How can you simplify this? What are you expected to do? It's simple. This is 5 to the power of 2, then times y to the power of 2. Now, you notice that although the bases are the same, but that's not our business. Their powers are, the bases are different rather. The bases are different, but that is not our business. Our interest is the powers. The powers are the same. So you factorize the powers. This is the same as 5 times y. Pull out the power. If you pull out the power, you're going to get 5y squared. Is it 5y squared or 5y in brackets and then square? This is the way you can get the answer. This is the way. One can decide to say, okay, or you go straight and you do 5 square. 5 square, yeah. Because this square will be distributed to both of them. 5 square is 25. 5 square is what? 25. So this is the same as or 25 and then y squared. Something like this. This is an alternative. Good. I think this is the most simplified term. Okay, this is the most simplified term. But I've just shown you that one can just write 5y and then you pull out your what? Your 2. So take note of all these that we have done in today's class. Take note of all these we have done in today's class. We are going to use it to solve interesting questions going forward. Are you following, right? Under indices. And this is what I'm going to do. I might not come on live again through GMAT41's YouTube short. Through GMAT41's YouTube short on this channel. The short video sections, just 3 minutes, 2 minutes. I could just solve some things, okay, fast. Using the knowledge of all the things I've explained in this live class. Don't miss out on these GMAT41's short videos. Don't miss out in them because you will need them. You will need them. Most of them are going to be professional exam questions solved in a twinkle of an eye. So you don't think that those things are difficult. They are not. They are very, very simple. Look at this question as I conclude the class for today. Imagine I give you 5 to the power of 2x minus 1 times, let's say, 3 to the power of 2x minus 1 equal to 1. Solve for x here. Solve and get the value of x in this question. What would you do? That is just a simple term. I can still make it much more complex. I can decide to divide this by 15. Can decide to divide this by what? 15. If I divide this by 15, 15 is same as 5 times 3. You split, then apply. Yeah, it'll be something like this. So you see, to solve this question is very simple. You use the knowledge of power law of indices. Nothing is there. This and this, they have the same power. They have the same what? Power. So you factorize the common power. You're going to write this as 5 times 3 in brackets, pull out 2x minus 1, which is the common power. So you pull out just one of them. So let me just quickly show you a rough work on this. Or should I? No, I won't. Solve this. Solve this. I won't. I'll meet you in the YouTube. That's GMAT41's YouTube short. Are you following, right? Tomorrow I'm going to drop the solution to this. But I've given you the idea. Nothing is there. Factorize 2x minus 1. Then you have 5 times 3, which will give you 15. 15 raised to power 2x minus 1 equal to 1. Think of what to do to this 1 to get common base, because this is initial equation. In fact, I will tell you that the answer of this is going to be 1 over 2. How? I'm going to see you tomorrow under GMAT41's YouTube short, like I said, and you're going to love it. Just the knowledge of everything we have learned from this class will apply them from tomorrow as I solve lots of questions this week on indices. Take note, on Wednesday, when I come on live, what do we have on Wednesday? What do we have on Wednesday? Yeah, Chick Chi, you're on point. Chick Chi, you're on point. So the 5 square times this square, fix error. What am I fixing? What am I fixing? There is nothing to fix. This is a question. 5 to the power of 2 times y to the power of 2. There is nothing to fix there. That is correct. Okay, that is correct. All right. Like I said, on Wednesday, I think we'll be taking, is it physics or chemistry? One of them also. Okay, I think it should be chemistry. Yeah, should be chemistry or so. I'm going to check the timetable. The timetable is going to be dropped also, if I've not already done so. But make sure 8 p.m. on Wednesday. I guess it's chemistry that we'll be taking in that class. Don't miss it out. I'll see you then. But remember, tomorrow I'm going to release a short video on certain questions on indices using the knowledge of what we've learned and other laws of indices together. Take good care of yourself. Good night. Chick, that was really good. Thank you. I am glad that you loved and enjoyed the class. So guys, good night, right? Do have a wonderful night rest. See you tomorrow.